Good morning students. Today the topic is CPU scheduling algorithm, which is a continuation of a previous video, and where I have explained what is first come first serve scheduling algorithm with an example. So where there I have told how to calculate average waiting time, average turnaround time, average response time. Okay. So before going to the second one, which is called as shortest job first. Shortly it is called as SJF scheduling algorithm. Before that, there is also one more concept of first come first serve scheduling algorithm. Let us see it today. Okay. See, which is called as what? Convoy effect. See, convoy effect, which is important for 2 marks and which is a problem of a first come first serve scheduling algorithm, where you can easily understand which is like a drawback, which is like a disadvantage of a first come first serve scheduling algorithm. Okay. So like where, so what is this convoy effect? See, once we talk about this convoy effect, it is a phenomenon or it is a property of a first come first serve scheduling algorithm. So what happens? See, with an example, when we talk about like a 3 process, when you have 3 process with the respective burst time with the previous example, so where it is taken like this. So here see P1, because it comes under first come first serve scheduling algorithm, whichever process is there first, that only will be using, or that process only will get a chance of using CPU. Okay. So here P1 with the 20 milliseconds, P2 with the 3 milliseconds and P3 with the 4 milliseconds. So here what happens? P1 is with what? Large burst time. Okay, and P2 is with what? Minimal, like a less, which is called as 3, and P3 is also with the less burst time. So what is this? See, convoy effect is nothing but, so where the small, like the process with the small burst time, the process with the small burst time should wait until the process with the larger burst time. Why? Because like this, because it comes under what? First come first serve scheduling algorithm, and a process which comes first, that only will be getting a first chance of execution. Okay, even though the process with the least burst time, it should wait until the process with the larger burst time if it is coming first. Okay, if the process is coming like as, because it comes under first come first serve scheduling algorithm, whichever process comes first, that process only will be getting a chance of entering CPU, even though its burst time is high when compared to the remaining process. Okay. So what you can understand, the process with the least burst time should wait until a completion of a process with the higher burst time, because what? The concept is depending on what? First come first serve scheduling algorithm. So how you can understand? See, like this means all small process have to wait for one big process to get off the CPU. This effect itself, it is called as what? Convoy effect. Okay, so this is an example. See, P3 and P2 is with the less burst time, but it should wait until P1 completes. Okay, once P1 completes, then only a chance will be given for P2. After P2 completes, then only a chance will be given for P4. Okay, because it comes under first come first serve scheduling algorithm. So where to overcome this? So this convoy effect will be avoided, or this can overcome by using a second one, which is called as what? Shortest job scheduling. Okay, shortest job first scheduling. Shortly it is called as SJF. Okay, as the name itself it is telling. So what happened? Whichever process is coming, or whichever process with the burst time, with the least burst time, the process with the least burst time, that process will get a first chance of execution. Okay, I'll repeat. So what is this shortest job first? A process with the least burst time, the process with the less burst time, that will be getting a first chance of execution, which is not like first come first serve scheduling algorithm. In first come first serve scheduling algorithm, what happened? The process with, like, whether it is least or it is more, whether the burst time is less or more, if the process is coming first, that process only will go for execution fast. Okay, but here see, under this, the process with the least burst time. In this example, see, there are 4 processes. Okay, the table is given with the 4 processes, P1, P2, P3, P4. In this, like you can see, burst time is given 5, 10, 6, 2, which is the smaller one. P4 is the smaller one. Okay, P4 with the least burst time. The burst time of the P4 is how much? Only 2 milliseconds. So in this, what happened? Process 4 will go for execution first. Okay, like here. And one more thing, you may get it out here. If 2 processes have a same burst time, if 2 processes have a same example, see, if there is like one more process, like something, see P5, there is, I am explaining P5 with the 5. See, I'll repeat, P5, there is another process which is called as P5 with the burst time called as what? 5 milliseconds. But already there is another process which is called as P1, and what is the burst time? 5. So there what happens? If 2 processes with the same burst time, there again a concept comes which is called as what? First come first serve scheduling algorithm. Okay, how? See, like as per this, very first P4 will go. P4 will go for execution because 2 is a minimum. After 2, which is the next? 5. Okay, it is nothing but the burst time is 5 here, and after P4, P1 will go. okay, P1 will go. Again, the burst time when compared to burst time, P5 is also having 5 and P1 is also having 5. So there a priority comes, how first come first serve scheduling algorithm will be applied there. So after P4, P1 will go, after P1, P5 will go. Okay, because the burst time is common. The burst time is common. Okay, so here what happens? P1 will go, after P4, P1 will go, after P1, P5 will go. Okay, because P1 has come first when compared to the P5. Okay, so this is a way how. So this is a way how, like where the two process with the same burst time, even though in a shortest job first, that will be applicable there. Okay, now see, as I told you, in this shortest job first, whichever process with the least burst time, that will go for execution first. So as per this example, see, very first P4 will go. Why? Because P4 with the 2 milliseconds, that is the least burst time. After P4, P1. Okay, P1 with the least burst time. After P1, P3 again with the 6. Okay, after P3 you have the last one, which is called as P2 with the again 10 as a burst time. Okay, so now let us go with the Gantt chart. See, it is already told how to write a Gantt chart. It is one of a very important, because once the Gantt chart is written properly, then all the calculations will be done it will be correct. Okay, so now here see P4 starting with 0. Why P4? Again it is shortest job first, where you have a 2 milliseconds. See, P4 starting with 0 and P4 with what? 2. Okay, after that you have the next one, which is called as P1 with the 5 milliseconds, and P1 will be written 2 plus 5, you will get as what? 7. Okay, and you have after P1 you have P3 with the another less burst time. Okay, P3 will come 7 plus 6. See, 7 plus 6, how much you will get? 13. Okay, 7 plus 6 you will be getting 13. After that, you have the last one, which is called as a P2 with the burst time called as 10. So 13 plus 10, you will be getting how much? 23. So this is the way how you write a Gantt chart. Okay, now once the Gantt chart is written correctly, then you will be going with the calculation. Once we talk about this, see, like already in a previous video I have told what is the formula to calculate average waiting time, turnaround time, response time. And you also know that to calculate like average waiting time, you want starting time minus arrival time. Okay, what is starting time? See, for P4, the starting time is 0 and arrival time is always 0. So where you got 0 minus 0, you got as a 0. And again see, again this calculation is also very important, because see, as per the Gantt chart only you should take the calculation. It is not like you will take P1 first, P2 first, then P3, P4. It is not like that. So the way how you have written Gantt chart, which process is coming first, for that process only you start calculating first what is the average waiting time. Okay, so as per the Gantt chart, P4 is coming first, P1 is coming next, P3 and P2. And again very similar to that, very first P4 with the starting time minus arrival time, you will get 0. And after that you have P1, starting time is 2 and arrival time is always 0. 2 minus 0 you will get 2. And you have P3. See, P3 starting time is 7 and arrival time is 0. You will get 7. And P2 starting time is 13 and arrival time is 0. You will get 13. So once we go with the average, you have 0 plus 2 plus 7 plus 13 divided by 4. And why it is 4 here? Because number of processes given in a table is how many? 4 processes. So because of that you take an average of 4 and you will be getting 5.5 milliseconds as a average waiting time. Okay, so this is average waiting time. And the next one you have average turnaround time. So again you all know the formula how to calculate average turnaround time, like where process is equal to a finish time minus arrival time. Okay, finish time minus arrival time. So that is the formula. So again coming to the same thing, P4, as you all know, which comes on the right side, that is called as a finish. The process P4 finished its execution at 2 milliseconds. So P4 is equal to 2 minus arrival time is 0. 2 minus 0 you got 2. And P1 is finished with the 7. 7 minus 0 you got 7. And P3 finished with the 13. 13 minus 0, 13. And P2, last one, finished with the 23. 23 minus 0, you got 23. Okay. So again coming to an average, 2 plus 7 plus 13 plus 23 divided by 4. Again you got 11 point, you will be getting 11.25 milliseconds. Okay, so this is the way how you calculate turnaround time. And the last one you have, which is called as what? Like a average response time. And you all know that average response time is equal to first response minus arrival time. And what is first response? when a process got a chance of execution, when a process got a chance of entering CPU, that itself it is called as what? First response. So once we go with the calculation of first response, you will get same. You will get the same calculations, and the average response time also will be very similar to the average waiting time, 5.5 milliseconds. Okay, so this is the way how you calculate average waiting time, average turnaround time, average response time by using or by applying shortest job first. Okay, so the name itself it is telling shortest job first is nothing but the process with the least burst time, the process with the shortest burst time, that will be going first for execution. I'll repeat, like where if two processes have a same burst time, so there what happened? First come first serve scheduling, like first come first serve scheduling algorithm will be applicable there. Okay, so this is the way, like this is the second one which is called as shortest job first scheduling algorithm. Thank you.